The two hands of the same tincture, molecular chirality and enantiomers. Brother Ansevald had prepared remedies for the abbey infirmary for 30 years, and in all that time he had never seen two batches of the same medicine behave like these two. The emperor's gout had worsened through the winter, and word had reached Aachen that the abbey's featherfew tincture, brewed from the same dried herb, the same wine spirit, the same mineral salts measured with the same scruple, had eased such swelling before. Ansevald prepared it himself, as he always did, steering the copper vessel with his right hand, the way his own master had taught him for 40 years earlier. But his hands had grown stiff that winter, and for the second batch he called his novice Wulfric to finish the steering. And Wulfric, left-handed since birth, worked the ladle the only way his body knew, circling the opposite way round the vessel. By every test the two brothers possessed, the resulting tinctures were the same substance, equal weight, poured from the same scale, identical color, a deep amber held to the window, identical smell, the same bitter green edge of featherfew. Even the taste, when Ansevald touched a drop to his tongue against every rule of the infirmary, was indistinguishable, the same sharp herbal sting, left flask and right. And yet, when the two vials were sent to Aachen under seal and administered a week apart, as the physicians insisted on doing to be certain of no error, the emperor's own steward reported that the first dose, the batch, stirred by Ansevald's practiced right hand, brought the swelling down within 2 days, as it always had. The second dose, from the batch, steered by Wulfric's left, did nothing at all. No improvement, no harm either, simply nothing, as if plain water had been sent instead of medicine. Ansevald was certain some error had crept into the second batch, a mismeasured herb, a fouled vessel, a spirit gone flat. He remade it 3 times, watching Wulfric's hands as closely as a hawk watches a hare, and each time the result was the same, identical to the eye, the scale, the nose, the tongue, and identical in its uselessness. It was a trader from the northern coast, passing through the abbey that spring with amber and Norse iron, who finally showed them why. He carried among his goods a clear stone the sailors used to find the sun through cloud and fog, a stone that split a single beam of light into two, bending it strangely as it passed through. He held it first over Ansevald's flask, then over Wulfric's, letting a shadow of window light fall through each, in turn, onto the scriptorium floor. The light bent one way through the right-handed batch. It bent the other way, by the very same measure, only reversed, through the left-handed one. They are not the same brew wearing two faces, the trader said, turning the stone in his fingers. They are two brews wearing the same face. Everything your senses can weigh, they share, but the way they turn a beam of light apart, that they do not share at all. One turns it toward the sun's rising, the other turns it towards its setting. And whatever it is in the emperor's own body that the medicine must fit against, like a key into a lock, apparently only turns to open for one of them. Ansevald sat with that a long while, before he understood what the trader, without knowing the word for it, had actually shown him. The two tinctures were built from precisely the same atoms, arranged in precisely the same bonds, in precisely the same proportions. What differed was only the handedness of that arrangement, a mirror image, not a different substance. And the body, it seemed, was no less handed than the steering arm that made it. What the trader's sunstone revealed, and what Ansevald could not yet name, is the phenomenon of molecular chirality, the existence of molecules that are non-superimposable mirror images of one another, called enantiomers, despite sharing an identical molecular formula, identical connectivity of atoms, and for most ordinary physical properties, including boiling point, density, solubility, and even taste and smell in many cases, identical behavior. Chirality arises most commonly from a stereocenter, typically a carbon atom bonded to four different substituent groups, which permits two distinct spatial arrangements related as mirror images, much as a left hand and right hand share identical parts, arranged in mirror reversed order. The two enantiomers of a chiral molecule differ measurably in exactly one classical physical property. They rotate the plane of linearly polarized light in equal magnitude, but opposite direction, a phenomenon called optical activity, first systematically studied by Jean-Baptiste Biot in the 1810s and famously resolved at the molecular level by Louis Pasteur in 1848, who manually separated crystals of sodium ammonium tartrate into two mirror image populations and showed each rotated polarized light oppositely. The consequence dramatized in the tincture is that biological receptors, enzymes, and transport proteins are themselves overwhelmingly chiral, being built from homochiral L amino acids. A binding pocket shaped to accommodate one enantiomer as a lock accommodates one key will frequently fail to bind or bind with radically different affinity and effect its mirror image counterpart. This is not a minor laboratory curiosity, it is a central concern of pharmaceutical chemistry, where one enantiomer of a drug may be therapeutically active while its mirror image is inert, differently metabolized, or in the most serious historical case, actively teratogenic. The thalidomide tragedy of the late 1950s and early 1960s involved a sedative whose two enantiomers had sharply divergent effects on human development, a case that reshaped global drug approval regulation around mandatory single enantiomer testing chiral resolution, rather than assuming a racemic mixture behaves as one substance. Modern graduate organic and pharmaceutical chemistry accordingly devotes substantial attention to asymmetric synthesis and chiral catalysis methods for producing a desired enantiomer selectively, since a racemic mixture, equal parts of both mirror images as an unguided synthesis, typically yields squanders half its product on a form the body may not recognize, or in the worst case, actively harm from. Thanks for tuning in to another episode. See you next time.